Alrighty. To graph a rational function with holes, you're essentially following the steps on graphing a regular function, which is right here in your handouts also. So you want to find the x-intercept, aka setting the numerator equal to 0. Find the y-intercept by plugging in x is equal to 0 to everything and then solving for y. Finding your vertical asymptote by looking at your denominator and setting that equal to 0. Finding your horizontal asymptote by looking at your degree of your exponents and see which one's bigger. If top is bigger, then you don't have a horizontal asymptote. If bottom is bigger, your horizontal asymptote is 0. And if your degrees are the same, then you're going to divide your leading coefficients to find out what your horizontal asymptote is. And then you are just going to find that, sketch all of that out in your graph, and then connect the dots. So in number 1, you're going to find the x, y, vertical, horizontal, whole, domain, and range. But before you do all of that, you got to make sure that everything is simplified. So I'm going to go ahead and simplify this out. And then once I simplify that out, you'll notice that I can simplify the x minus 1. That's going to give me negative 2x minus 3. I don't have an x-intercept just because I can't set my numerator equal to 0, because if I do, negative 2 is equal to 0, which really doesn't make sense. My y-intercept is me plugging in 0 for x. That's just going to be 0 2/3. My vertical asymptote is me looking at my denominator and setting that equal to 0, so x is equal to 3. My horizontal asymptote is going to be at 0 because my exponent is bigger at the bottom. And 0. We kind of know this already because if I don't have an x-intercept, then most likely your horizontal asymptote is going to be at 0. Your whole is going to be whatever your common factor that you canceled out. In this case, we canceled out x minus 1. We're going to set that equal to 0 to get 1. And then to find the y value, you are just going to substitute in the y value into your simplified function. And that's going to give me 1, 1. I'm going to focus on the domain and range at the very end, just because I want to look at the graph and visualize it using the graph. Given all of these characteristics, I can graph my vertical asymptote, my horizontal asymptote, my y-intercept, and my whole. I don't like black. Let me do red so that you can see it. Three. I have a whole at 1, 1. And then I have y-intercept at 0 2/3. Oops. Your whole should be an open circle just because we can't include it. Because remember, at 1, it's going to be undefined. So that's one of your restrictions. I'm going to sketch the top left. Should look something like that. And then to find your bottom right, what you're going to do is use some symmetry. Remember that with a rational function, you have symmetry going on with your center of your asymptotes. In this case, my center of my asymptote is right here, so I know that I have symmetry along this point right here. This means that if I were to go down 1, right 2, down 1, right 2, it leads me to this point right here. Now, how do I know that 5, -1 is an accurate point? Of course, you can plug it in to find that point. So if I were to plug in 5, I'm going to get -2 over 5 minus 3, or -2 over 2, or -1, which fits my criteria right here. I could also do the same thing with my y-intercepts. This was 2/3, so I'm going to go down 2/3 and then right 3. Down 2/3, right 3. That's going to give me maybe this point right here. Once you do that, you could sketch it, and it gives you this thing right here. One thing to note that we used this coordinate, and this was a hole, to find out this coordinate right here. At 5, -1, there's not a hole because at x is equal to 5, it is included in my domain, so that's why this is a closed circle. My domain now is going to be from -∞ to 1, because at 1 we have this break, the hole, and then from 1 to 3, because at 3 we have this vertical asymptote that I can't touch, and then from 3 to infinity. My range, same thing, -∞ to 0, because at 0 I have this horizontal asymptote. Then from 0 to 1, because that's my y value of the hole. And then 1 to infinity. Same thing with number 2. What I'm going to do is go ahead and factor out the numerator and see what I can cancel, if there is anything I could cancel. You'll notice that you'll have 2x minus 2's on top, and there is only one common factor of x minus 2. Don't cancel this x minus 2 right here because there's not a buddy that can cancel out in the denominator. This will only leave us with 2x minus 2 or 2x minus 4. We can graph this pretty easily because it's just a good old y equals mx plus b linear function. However, we don't have an x-intercept because our hole is at 2. And if I were to plug in 2 right here, you're going to get 0. So I don't have an x-intercept. But I do have a y-intercept at -4 because this is a good y equals mx plus b. Your b value is -4. Don't really have a vertical or horizontal asymptote just because it's a linear function right here. So if I were to graph this, I'm going to graph my y-intercept at -4, up 2, right 1. Notice how I have a hole at 2, 0, as I should. And then just graph it. Your domain is going to be from -∞ to 2, union 2 to infinity because I don't include 2. Your range would be from -∞ to 0, union 0 to infinity because my y value has a break at 0. Same process for number 3, where I have x squared plus 2x over x squared plus 6x plus 8. I am going to go ahead and factor out the numerator and denominator. You'll see that I have x plus 2 that cancels out because I have common factors there, which means that I have a hole at -2. To find the y-coordinate, I'm just going to plug in -2n to figure out what that is in my simplified function, which means that I have a hole at -2, -1. My x-intercept is whenever I have my numerator set equal to 0. So in this case, x is equal to 0 since my numerator is just x. My y-intercept is whenever I have x is equal to 0, so 0 over 0 plus 4, or 0. So both 0, 0 would be my x and y-intercepts. Vertical asymptote is at -4 because my denominator, I can't have -4. It's part of my restriction. And then my horizontal asymptote, looking at my degree of my exponents, I can see that I have 1 right here and 1 right here. Looking at my leading coefficients, my horizontal asymptote is at y is equal to 1. I'm going to go ahead and plot everything I know. So this includes my horizontal asymptote at 1, my vertical asymptote at -4, my hole at -2, -1, and my y-intercept and x-intercept at 0, 0. I'm gonna go ahead and sketch my bottom right. And like I said, you want to have symmetry going on in terms of your center of your asymptote. So this is going to be my center, symmetry across that point. In this case, I'm going to go up 2, left 2, up 2, left 2 to get to this point right here. Even though we use a hole as a reference point, this point is going to be a closed circle because we include it. And then same thing with my y and x-intercept. Up 1, left 4, up 1, left 4 right here. Oop. That is how your graph should look like. Of course, you're going to have pencil, so it's going to be one color. Your domain, remember this is going to be all of your x values except your restrictions. And I know based off of my graph, my restrictions are at -4 and at -2. Because at -4, I have a vertical asymptote. And then at -2, I have a hole. So -infinity to -4, -4 to -2, -2 to infinity. Likewise with my range, I have -infinity to -1 because of my hole right here at -1. And then my horizontal asymptote, I can't touch 1. And then 1 to infinity. Go ahead and pause this video and attempt maybe 4 before I give you the graph for number 4. So pause this video, try it on your own, factor it, do all of that good stuff, and then check your answers by playing the video. I'm not going to do 5 and 6, but the key is posted on Canvas. All right, for number 4, you are going to factor out that -2. And you're going to factor out that x. Your numerator is still a differences of 2 squares, so you could still factor that out. And then, hey, I can cancel out the x plus 1 because it is a common factor. Since it's a common factor, I know that I have a hole at -1. But where's your y value? Well, just substitute it in. Your y value is going to be at -4. Given that this right here that I am circling is your simplified function, my x-intercept is going to be at 1 because if I were to set this equal to 0, your numerator x is going to be 1, so 1, 0. Your y-intercept is whenever you have x is equal to 0. In this case, if you have that 0 times -1 is -1 times -2 is 2. But then your denominator is 0, so 2 over 0 means that your y-intercept is undefined. So there's not one. And this makes sense because, hey, if I were to look at my vertical asymptote, my denominator, x can't be 0. So if x can't be 0, aka your vertical asymptote, your y-intercept is none. It's very similar to this one right here, where my horizontal asymptote was 0 and my x-intercept was none. My horizontal asymptote is going to be -2 because if I were to look at my exponents, they are the same. So I'm going to take my leading coefficients of -2 and 1 to get -2. Going to graph everything I know. So x is equal to 0 is my vertical asymptote. Y is equal to 2 is my horizontal asymptote. My whole is at 1, -4. -1, -4. And then my x-intercept is at 1, 0. And what you'll notice is that you already have symmetry going on here. So if I go up 2, right 1, up 2, right 1, you get that coordinate right there. However, you can find more coordinates in this function by plugging in a point. So what I'm going to do is, because this thing right here is easy enough for me to plug in, I'm going to plug in 2 and see what happens. If I were to plug in 2, I'm going to get -2, 2 minus 1 over 2. So -2, 1 over 2, -2 over 2, or -1. So at 2, I have -1. And then if I were to do symmetry there, I'm going to go down 1, left 2, down 1, left 2 to get this point right here. Sketch it, and this is what you get. Your domain is -infinity to -1, -1 to 0, 0 to infinity. Your range is going to be from -infinity to -4, -4 to -2, -2 to infinity. This is because you're at your domain. At -1, you have your whole, and then at 0, you have your vertical asymptote. For your range, we have -4 because there's a whole at y is equal to -4, and then you have your horizontal asymptote at -2 right here. One thing, important thing to note about what we just graphed is that there are some non-canceling factors. So for example, here in number 4, we canceled x plus 1. So this is a common factor, and this is a canceling factor. X plus 1 is a canceling factor. X minus 1 is a non-canceling factor in the numerator because it's on top, and x is a non-canceling factor at the bottom. Same thing with number 3. This x plus 4 is a non-canceling factor in the denominator. This x is a non-canceling factor in the numerator. And x plus 2 is a canceling factor in the numerator and denominator because they both cancel to get that whole. Now, one thing to note is that if you were given a graph like number 3, like this, and I didn't give you the equation, so if I give you something like this, how would you give me the equation for it? One way to do that is basically work backwards by finding your x and y intercepts, finding your horizontal and vertical asymptotes, and finding your whole. and all of that good stuff. So looking at this, I know that because I have a vertical asymptote at -4, it has to be in my denominator. I also know that because I have a hole at -2, I need to have a canceling factor at the top and at the bottom to cancel. Also, let's look at the x-intercept. My x-intercept is at 0, 0, and remember, to find the x-intercept, you want to set the numerator equal to 0. So if x plus 2 was canceled out, the only thing that's left should be an x, because that x represents your x and y intercept. Well, your x-intercept in this case, since it's in the numerator. You also want to look at your degree, and if you were to cancel out this and this right here, you're left with x over x plus 4. Since this is a degree of 1 and this is a degree of 1, and your horizontal asymptote is a degree of 1, you know that you don't have an a value. So based off of this, we basically found this out based off of our lovely graph right here. So this right here we found, and it matches up with this right here. Same thing with number 4. If I were to try and find the equation of the graph given this, I know that my vertical asymptote is at 0, so I need to have an x in the denominator. I also know that since this is a hole at -1, I need to have x plus 1 on top and x plus 1 on the bottom. I also know that because this is my x-intercept at 1, I need to have an x minus 1 on the top. Now, we're close because we already have x plus 1, x minus 1, x, and x plus 1, which is what we found right here. Except, how do we find out, or how do we know that we have a -2 as my a value? Well, remember that we have to look at my horizontal asymptote, and looking at my degree, if I were to cancel out the x plus 1 and the x plus 1s, I have a degree of 1, and I have a degree of 1, so this means that my horizontal asymptote deals with my leading coefficients. In this case, if my horizontal asymptote is at -2, I need to have a leading coefficient of -2 whenever I divide it. So in this case, I'm going to have -2 on top to give me -2 x plus 1 x minus 1 over x times x plus 1 as my equation, which, guess what, we found right here after we simplified this right here. Now, the reason why finding the equation might be important is because it tells us a couple of things if you were given this graph. It tells us that x plus 1 is a canceling factor. It tells us that x minus 1 is a non-canceling factor in the numerator, and that x is a non-canceling factor in the denominator. It also tells us that x right here means that we have a vertical asymptote at 0, we have a horizontal asymptote at -2, we have an x-intercept at 1, and so forth. So the graph and the equation will give you a lot of details about the characteristics that we'll ask for in the FRQ. Like I said, you could do 5 and 6 on your own. I'm not going to do that. It won't be posted on Canvas, so you could find out how to graph 5 and 6, or you can plot these on Desmos and see the characteristics and just know how to find out your x, y intercepts, your vertical, horizontal asymptotes, your hole, and your domain and range.